In this video, I introduce entropy and complexity in machine learning. When some cream is poured into a cup of coffee, at first the coffee and cream are separated, and over time, the two liquids diffuse until they are completely mixed. For a closed system, the entropy is increasing over time, in accordance with the second law of thermodynamics. At the beginning, when the liquids are completely separated, in a highly ordered, the system has a low entropy. When the liquids are completely mixed in disorder, the system has a high entropy as shown here. At the beginning, the complexity is low since the system is easy to describe. When the curve is in an intermediate state, the system is harder to describe. Namely, the system has a high complexity, as shown here. The complexity then decreases over time. The system has a low complexity at the final mixed state, as shown here. Suppose that chi is a finite or countable set, and x is a random variable taking values in chi with a distribution p. Some entropy of a random variable x is given by this formulation, which maps the distribution of a random variable to a real number. Kolmogorov complexity k of a finite object x is defined as the length of the shortest binary description of x, or the shortest computer program that outputs x. The entropy of n-byte string x is identified with his Kolmogorov complexity, namely the length of the shortest computer program that outputs x. Shannon entropy and Kolmogorov complexity are all maximized by random or generic distributions. Shannon entropy measures the average uncertainty of a random variable, representing the average amount of information needed to describe an outcome. Kolmogorov complexity measures the information in a single specific object by finding the length of the shortest possible description or program that can generate it. Kolmogorov complexity measures the mapping from a description y to a string x executed in an effective way. If D is a program that outputs a string x, the shortest D is a description of x, namely the length of the description is the length of D as a character string, multiplied by the number of bits in a character. In AI and machine learning, Kolmogorov complexity is applied to optimize neural networks with a lower complexity, which tend to generalize better results on new data and reduce model overfitting, as shown here. For more details, please check with these references. Thank you. Bye.